What's up, friends? Hang in there for a minute. I'm a little winded. Hold on, y'all. I'm getting everything set up. Dang nation. There we go. We're loading up. I might be able to see the chat here in a minute. All right. So if this thing works, this is going to be the score. And it's going to be something I wanted you guys to see, to be able to do. What's up, Bruce? Not only was I able to get it, I did a little bit of Googling on it. Apparently the Sports Art 6310 HR, which is what this guy is. Well, apparently they retail used for a little over $3,000. But that is not what I want it for. I believe me, I just got enough of a workout bringing this damn thing down here. First off, let's plug it up, because it's absolutely laughable sometimes that somebody will take something like this and they'll just throw it out just because, I don't know, they ain't got room for it or something. All right, I hear controls. I don't see the display. Let's check the speed controller. Ah, I see the problem. They threw it out because the motor is slipping. It's all right, though. Let's see if this thing actually goes. Okay. So it successfully works. Now we'll check the incline to see if that goes. It's lifting. I don't know. Can you see that on screen? It's actually working. Now, another thing that's going to be good to know if it works or not is this e-stop. the e-stop does work. So if you can believe it, we do actually have a fully functioning treadmill here. If you guys want to look it up, I don't know if you want to Google it or whatever, it is a Sports Art 6310 HR with a personal cardio advisor. I'm guessing HR stands for heart rate. I'm going to turn you this way so we can talk. I'm going to get in the shade because I am a little bit hot. Lugging that thing down here was a pain in the ass. Whew. So that's a good sign. We got a functioning treadmill, but that's not what we want it for. We want it because this thing can be turned into a machine tool. It can be repurposed into all kinds of things. Treadmills are a gold mine. And like this instance today, some people just end up throwing them out. So what do you think, guys? Well, I only got one person watching. Did I lose everybody? I guess I did. There's the second person hanging there for a minute. I got to do some cleanup because live was acting stupid for me a couple of seconds ago. Let's delete that one. We'll delete this other one. There we go. Can you guys hear me okay? Yes? No? Maybe so? Let's bring you guys in so you can see a little bit. I can most definitely see why somebody might have thrown this out. I mean, they took the cover off for reasons unknown. I'm not sure. But one of the big problems is that belt over there. It doesn't seem to have enough tension. Let's try to fire this thing up again. All right, so the thing is working. No worries, Riddick. Thanks for coming in, man. All right, so we've got a good running motor. The belt has seen better days. The belt has definitely seen better days. What we have on this side is called a Hall effect sensor. That small spinning doohickey right here is passing through this sensor, and every time there's a little tab that runs past it, and it's calibrating how many tabs are going by, and that tells it how fast the motor or how fast the belt is turning. So that seems to be working. The speed control is up here. Let's give it the beans. Well, it doesn't seem to have a problem running. Let's check out the other functionality right here. This is what's called a linear actuator. And what it basically does is it has a corkscrew that goes up and down that raises and lowers this side of the treadmill. Let's try it out, see if it works. Yeah, it seems to be working just fine. All right. So the last thing we'll see, we'll check this emergency stop, see if it does what it's supposed to do. All right, well, for all intents and purposes, I can't see any reason other than this belts condition maybe that this was thrown out. But it's got a wealth of parts that we'll be able to use and repurpose for other stuff, which is definitely going to be interesting to do. Why do I want this particular treadmill so much? Let me show you. Oh, that, my friend, says that it is a 4 horsepower continuous heavy duty treadmill motor. It's a DC motor, which means it runs on brushes and direct current. And we have a phase converter in here that converts the 110 AC coming in from the wall to a direct current of 100 volts. With, again, that Hall effect sensor, a pair of step-up transformers, looks like, to be able to get the DC current up where it is. We have a DC motor for the linear actuator that runs at 36 volts at 3 amps. We've got an electromagnetic filter back there. We did, Heather. Whew. This sucker about wore me out, but we got it. And you wouldn't believe it. The whole thing works just fine. Now, the belt has seen better days. But it does, in fact, work. Let's lower the incline. Bring the speed down here. Interesting. Let's drop the speed all the way. Oh, we have limited response or no response from the linear actuator. Is it working? I think I might have hyperextended the incline actuator, but that's okay. This is most definitely doing what it was meant to do. Absolutely. We'll shut that guy off. I think we have some display here, but it is very faint. Turn it into a pizza machine. That might be a hell of an idea. Maybe I could turn it into a pizza machine. Or maybe, just maybe, it is most certainly that. And I think I found another reason why they may have got rid of it, because this linear actuator doesn't seem to want to work, which is interesting. Let's try to reconnect this. Should have no signal. Okay. Let's give that a little bit of persuasion. Okay. Well, now we know why they threw it out. The linear actuator will go one direction, but it won't go the other. All right. So let's start dismantling this sucker. What do you think? I'm excited to see that we've got that a 4 horsepower continuous duty motor is an incredible find, because at the end of the day, that means that it has a 100% duty cycle. And what a duty cycle is that most motors, when you look close enough at their specifications, they'll provide you a duty cycle, which means that that's the percentage amount of time it can run in an hour before you got to stop and give it a rest. Welders, for example, have somewhere around a 15 to 20% duty cycle, meaning every hour, the smaller induction welders, you can only run them for maybe 8-10 minutes. And then you have to let it rest for the rest of the hour. But with this being continuous duty, that means that, hey, Pilato, check out the score, man. dropped off about a half a block away, and we had the thing running. Yep. This is absolutely an incredible find. I'm glad that we got it. Now, why did we want this so much? Because that permanent magnet DC motor and that PCB come together to give speed control. So that's a variable speed motor, obviously, as you can control the speed at which the treadmill will turn. Absolutely. I think this is phenomenal. And the best part about this, as I said, is that this is a 4 horsepower continuous duty, which literally means that this thing can run continuously. And it could run non-stop at 4 horsepower and never have a problem. So that's a phenomenal find. I think it's great. So I think I'm going to let you guys watch me for a little bit while I get after trying to tear this apart. What do you think? And I think the first thing we need to do is tear after these rollers, because those will be important for the machines that we build in the future too. Let's disconnect the power. Forgive me, I won't be able to watch what you guys are saying in the chat, but I'm going to tear into this sumbitch and see what I can pull off. Pun entirely intended, because I'm going to be pulling off all kinds of shit. I don't need these, so let's get us some type of pry bar. Use the right tool, dingus. Beautiful VJ, how are you? Good to see you, friend. Two seconds in the midst of my cleaning, I forgot that I was cleaning and I stopped cleaning. Creation Dust, how you doing, friend? Glad to see you guys. Make sure to tune in to Creation Dust. He does wonderful chainsaw carving. The man is amazing. Then again, I think you've been at it for like, what, 6 months, something like that? You've been at it for a while. Had to have been at least 6 months. Present time where I am is about 1:30 in the afternoon. There's a pry bar. All right, let's get all this crap out of the way, because this thing has treasures for those of us who salvage and repurpose beyond what I think anybody's expecting at this point. This thing is going to have all kinds of goodies for us. I don't need any of this neoprene guards. What I am interested in is beneath it are 2 4-foot long pieces of aluminum extrusion, which might be useful in building the lathe. Hey, what's up, man? How you doing? Tearing up junk yet, the usual. There's somebody that fixes treadmills that's absolutely losing their mind at me right now. What the hell are you doing? That's a $4,000 treadmill. Well, technically, it's a $3,700 treadmill. But to me, as a treadmill, it's worth a whole whopping bucket. But it does give me a bunch of parts. Just what I thought. We got some nice aluminum extrusions down in here. That's going to be nice to have. We'll keep tearing in, get this whole thing apart, and I'll try to walk through every piece as I get it so I can tell you its potential functionality, how we can repurpose it and reuse it for building a machine tool. Let's go get this to the dumpster. Some common tools you're going to need is, of course, some type of screwdriver, and most definitely Allen wrenches. These guys are put together almost exclusively with hex bolts or with Allen screws. Save those washers and screws. And down there we've got our big hex key. So it's going to be 6mm. Yeah. Oh, those suckers are on there too. Sorry, it's tough to see the chat. I'll try to crane up there and look at it like an old man every chance I get. Let's see what we got. Anybody know what I'm up to today? Yes. I think that this is a more suitable motor for a machine tool, whether it be a lathe or if I decide to do something else with it. At the end of the day, when you look at most all your power tools, any one of them is just, it's simply a motor connected to some kind of drive output that allows you to exert force on something else. So anytime you can get a motor and output, well, you're in pretty good shape. Some of these bolts are pretty rusted in or seized, Loctited, something. There we go. If you guys are going to do that, notice I grabbed the vice grip right down at the base, because the more torsion I put on it, the more likely the Allen key is going to break. So the shorter you can make this distance, the stronger it becomes. So grab it down here. Don't try to grab it up here if you're going to do anything like I just did. These are some big, beefy aluminum extrusions. They don't look like they've been damaged or warped or thrown out of square. Good. All of these are relatively simple. They're just popping right out. Don't worry, I'll get to the juicy bits here in a bit. But before I tear into the motor and the speed controller PCB and all the electrical components, I want to get as much of this drive situated. Yep, big beefy piece of aluminum extrusion here. Got a interesting profile, but I'm sure it will definitely come in some use, even if it's nothing more than a straight edge for maybe a track saw or something. All right. Whew. This thing has been kicking my tail ever since I saw it. That's all right. Some people invest money. Some people invest sweat dripping on concrete. Yeah. This is where that part of the song came from. I'm sorry I can't really see. I'm just randomly talking. Hopefully I've given enough info that if somebody's got questions, chat will be able to answer. Otherwise, I will pop up time and again, take a look at the chat, see how things are going. Or I could just shut the hell up and ASMR it. Whatever y'all think. Just a second. I think I got a power tool for this. What did I win? I ain't won nothing. What I won is an agonizing, grueling afternoon of tearing this damn thing apart. Hopefully bringing you guys along the way so that we have a good time. Or at least you guys have a good time. All right, let's see. Did I win a gift certificate? What kind of gift certificate? I want a gift certificate for a free butt whooping in my driveway this afternoon. Welcome back, Hang Time. My impact driver. I have a socket attachment for it with an M6. Let's see if this doesn't make shorter work of this. %100. Beautiful. That's what I was after. Oh yeah, this is going to go much quicker now. Forgive me. I'll look again pretty quick. But the camera angle may not be the best. Sorry about that if it's not. Oh shit, that just slides off. I didn't have to bust that other one. Good. I would have had to have imagined, if I'd have thought about it a little further, I'd have realized they had to have done that in order to be able to put it together. All right, let's get the rest of this sucker apart. Oh, yes. This power tool is going to make it 1,000 times faster. Another one of our aluminum extrusion rails, which is good. Throw those to the side. We got our rear drive belt and drum loose. Ugh. Let's keep getting this sucker apart. The good news is it looks most of this is put together with M6 bolts. Which for simplicity of assembly, that makes sense. All right. So next thing we need to do is remove this drum. Which has most certainly seen better days. But it's covered and caked with crap. But the bearings seem to be rolling quite well. So that's going to give us a functional, looks like 25mm shaft. And some good bearings to go with it. As I thought, underneath here is just a piece of melamine that they normally lay down as flooring. And it's not usually connected with anything but maybe 3 or 4 bolts. They're not going to be M6. They're going to be something smaller. 1 second. Creation Dust says heavy duty rolling pin. You're probably right. It'll definitely be a heavy duty rolling something. It's not an M4, it's an M5. Okay. All right, Pilato. Thank you for coming in, brother. Yeah, just as I suspected. It's just maybe 4 bolts. It's going to hold this melamine on. We got some good rubber grommets. Let's check the front corners. Yep. Now I bet I could take that melamine right out. And we can go ahead and dispose of this, because we don't need that sucker no more. Whew. All right. We're a lot closer. So we've already unscrewed. Will these cross members come out? Yes, they do. Perfect. All right. Good pieces of rectangular steel tubing we can use later. All right. And we have some pilot bearings, which is awesome. Okay. That's yeah, we can go after that top drum. Flossie, how you doing? Mike isn't breaking. Mike is making. Mike is making a mess. That's what I'm doing. And if I dare say, pretty damn good at it. Oh, yeah. You slide right out of there, don't you? Yeah, you do. Good. Taking these apart seems like it's a daunting task. It's really not. They're a lot simpler than you originally perceived them to be. All right. Now this top drum is a little bit different. Stands a different challenge because it's actually connected to the motor with the belt. So we've got to raise it up, release it from the belt, and that will free it. All right. So that gives us another 25 millimeter or 1-inch shaft. Some more bearings. This again is running really well. Whew. Okay. And now we have a loose belt. Which I'm sure anybody else would throw away. Except, you ever want non-slip mats for your shop floor? Or mats that will resist glue, paint, stain on your workbench? I'm about to end up with about 6 feet of it that I got for free. Shut that down. You can make this stuff into all kinds of things. Weather sealing, soundproofing, anti-slip mats. You can even use it in a motor to make like an impromptu gasket if you have to. Very useful stuff. So we'll be rolling this up, adding it to the archive. There we go. Sorry, guys. I don't mean to be the grunt and groan kind of dude. Not trying to. It's just hot. It's a little muggy. I'm kind of wore out. I had to drag this thing half a block down the road. And it's, well, US probably about 160 pounds, 170. For all of you in Europe, it's probably 75, 80 kilos maybe. Northern Scott, yes, I do. I did more than enough exercise bringing this sandwich over here. Now I'm going to lay it on its back. So I can see how we get the reverse undone if we do. That's interesting. Can I get that loose? On the underside, what you couldn't see is that there's some M6 bolts, but they're in pressed in threaded inserts. I don't think I'm going to be able to get them. So let's just see if we can get the bolts. Perfect. All right. Next, we've got a set of bearings that they were using as guide control for the belt. Let's see if we can unscrew them bad boys. Yeah, we're going to be able to save those. Very nice. Big, thick, juicy compound bearings. They're running great. Those are good. If you're new to the channel, you know what to do. I don't even think I need to end that sentence. I would say the vast majority of the people who come across my feed will say that what I'm doing right now is boring. But there's a big chunk of you who don't think it's boring. Matter of fact, you find it pretty interesting. You are my people. Hit the subscribe button and stick around. You won't be disappointed. I'm doing ridiculous builds and stuff like this all the time. Okay. Oh. Oh, I'm going to try to run over here and take a second, read the chat. Monsieur Gauthier, good to see you, friend. Oh. All right. Hang time proclaiming his love for fingerboards in Germany. We're wishing June luck. I'm not sure for what. I'm sorry I didn't catch it, but whatever it is, I hope it's the best. Hello, Beating Crazy. How are you? I promise you're not just staring at some empty crap. I need to grab a few more tools. Continue our dismantling. And check the screen, make sure you guys can see okay. All right, Josh, thank you for coming in, man. Appreciate you. Okay, back to the part where it looks like I'm ignoring you guys. I'm sorry. But I got to get this undone. I got a cotter pin there. And I got a cotter pin there, which is going to let me lose one of the cotter pins. Of course, no, I didn't. All right. And we got a smaller cotter pin here connecting the linear actuator to the incline mechanism. So we'll pull that pin. Then start removing I guarantee that's bound up because I got so much pressure on it. What I'm removing is this slide pin that holds the linear actuator connected to the incline. We'll also grab a wee bit of persuasion to knock those guys loose. Hopefully that wasn't too loud. Let's get us a good punch, a cold chisel we can use as a punch. Knock these guys loose. Another piece of steel that I would probably get ready to throw away had I not looked just a hair further and realized that I've got some pretty decent sealed bearings inside here that I can probably gently punch out. Perfect. A little cleaning and some solvent, that thing will be just fine. So while I'm doing this, I'll talk to you about why I'm doing it. Even if I had absolutely no plans for the components that are in here, I jump on these treadmills like stink on caca, because more times than not, they're just such a treasure trove of parts and components that could readily be used and repurposed to help make something else work. This is probably the 15th treadmill I've taken apart. And I maybe have enough parts from before to reconstruct maybe half of one. That's how often I use the bits and bobs that are in these things. If I wanted to, I could even remove the pin and the shaft here and take those wheels, but I currently have a surplus of those. I don't need them. So we'll just discard this piece now. Well, we'll set it over here for iron recycling. We're getting awful close to the fun, juicy bits. The next one, I think, is undoing the other end of that linear actuator. And then we may be able to troubleshoot it, figure out why it wasn't advancing and retracting. The vast majority of the time, it's usually just because there's a loose connection or a bad wire or something got jarred so that it isn't properly seated and the circuit isn't closed. All right. Linear actuator is free. Let's undo these connections from the PCB. And there we have it. 136 volt, 1 kilogram, 1.7 kilogram per centimeter linear actuator, which would be handy. We could probably make a router lift out of that, actually, if we were so inclined to do so. Oh, a little bit too much sweat dripping on concrete. Let's go in here for a minute. catch our breath, and we'll talk about things so far. Tell me what you think. What do you think, guys? Not so hard, was it? Pretty easy to do so far. We got a little bit more to do. Shout out to everybody that's came in. Norm, I see you in here. Flossie, Francis. Glad to see everybody coming in, hanging out with me, taking a load off this Sunday. To reiterate why this was so important when I saw it, I'm always going to get jazzed about the fact that I found a treadmill. I'm always going to get jazzed. Mix me up. What am I going to use the motor for? Well, I have some options, but I'm curious what you guys are thinking. A belt sander is certainly on the list of options. Now, like I say, I'm always jazzed about the fact that I grabbed myself a treadmill. What really got me jazzed about this one is it's a commercial treadmill. Now, why is that so important? Because the treadmill that's going to your house, the manufacturers already fully expect you're going to buy it at New Year's, you're going to ride some bitch for 2 weeks, and that's going to sit in the corner hanging clothes off it. That's as bad as long as they figure it's going to last, or that it needs to. This is a commercial treadmill, meaning it was in a gym, and the gym had it, and that thing is running all day long, every day. Somebody's on it jogging. So what that ended up translating into is that it holds what's called a commercial constant duty DC motor. When you have a DC motor, it can only run for a certain amount of time each hour before it goes and starts overheating. Constant duty means that it has a 100% duty cycle. I could leave it on and it will run until rapture of the lights turn off. It's going to be fine. Plus, it's the added benefit of being 4 horsepower, which are absolutely big motors. They're really huge. So I can make a lathe with it. I can make a big belt sander with it. I can make all kinds of very, very powerful stationary power tools with it. Or I could upgrade one of the existing ones. I wonder what my drill press would do with a 4 horsepower variable speed lathe or 4 variable speed motor. Holy crap. That thing would drill a hole in the center of the earth by the time it was over. So that being said, I know I'm telling you, lugging that 200 pounds on me down the alley, half a block, 100 yards. I'm an old man. I ain't ready for all that. I wasn't expecting it. While I'm standing here, let's talk about this linear actuator. Basically, all this is that there's a monster screw inside here. And when I apply power to this motor runs a sprocket drive into here that turns the spur gear, that turns the screw, that raises and lowers this in and out. Tell me that wouldn't work great router lift. Or any other number of applications. There's always tons of things that I could do for this. I mean, if I was going to go with the industrial belt sander that Norm was talking about, I could use that to change the elevation and the thickness of what it's going to sand. There's a lot of things and a lot of potential. That's why I love grabbing these things anytime I see them, and I'm going to spend the afternoon ripping it apart. Ooh. Did the chat die? What happened? You guys still with me, or did I fall off? Oh, okay. This thing also has a huge amount of steel, which I'm going to need if I'm going to start running my welder here pretty soon. I can take my angle grinder and whack a lot of this apart and have good square stock rectangular tubing, repurpose a lot of this metal. What do you think? You want to get back after it? Whew. Who's making the run going by beer? Oof. Try to get y'all in here close. There we go. Y'all see that a little better? Oh, okay. That was fun. All right. Let's check the drive belt. Looks like it's in good, strong condition. If you're going to check these, what you want to do is flip it inside out and then give it a bit of a flex the opposite direction. See if you see any cracks or splits in the splines, which I don't see any. This belt is in perfectly good shape. Looks like it's relatively new too. So another good catch, component that we'll need. Heather asked, am I going to be able to use the frame for anything? I think I may, but not in the way I think everyone anticipates. I think the plan is to break it down and dismantle it to be able to use as raw steel stock. Now, when I get to this part, I got to be careful because many of the controls are up in the upper console. And when you think about it rationally, the only place that they could route any of that wiring is right up these two columns. So I know that there's wiring inside here I need to try to preserve if I can. So just unscrewing it and then yanking it off is probably not the best idea. Yep, 5 mil up there. I don't see that coming into the any time just yet. I think there's 2 more bolts on the other side. Grunt and groan, old man, grunt and groan. Okay, that's done. Doing all right, man. We got one that's stripped out. Since I got one that's stripped out, it's take you guys. Try to get a little education. Okay. Hopefully you can see that this one is absolutely spun out. No way for me to get that guy out of there. So what I'm going to do is grab another tool that I got. Try to educate you on it if you're not familiar with it, and derive us a solution. These are screw extractors, more commonly known sometimes by folks as easy outs. Now what they are is a very particular type of tap. And if you notice, this thread is reversed from what it normally would be. And what that gives me the ability to do is, as I drive this in, I'm exerting force that would loosen the nut or the bolt, but at the same time, these threads are driving deeper in there, getting a bigger bite on the inside of the hole, allowing me to probably get the thing out of there. I think I got enough depth. If I don't, then we'll drill a hole through it. We'll use this device. We'll get that messed up screw out of there. Yeah, I'm not going to get enough of a bite. So let's grab us a drill and a drill bit. To tear into some steel. We'll drill a hole for our extractor to go through a little bit farther. And that should give our teeth enough purchase for us to extract the screw. I'm going to move you guys just a little bit. I hope you guys can see okay. Let's get something a little smaller. Lockdown Lumber in the house. Good to see you, friend. Glad you was able to make it. Okay, let's blow us another hole in this thing. Okay, I think that gave us enough depth maybe. We'll try our screw extractor now. Yeah, it really is good to see you, Lockdown, man. I'm always catching you in the mornings. Well, into my time in the mornings. I'm going to do something that might seem a bit ill-advised, but I'm going to try to drive this in. See if I can't get a little more oomph on it. Yes, thank you. Show you're welcome to Lockdown Lumber. He's got a great channel. If you guys hadn't subscribed to him, you definitely should. He's been doing the thing ever since COVID. And look at that. What do y'all think of that, guys? Hopefully that's a cool trick. Hopefully it's something you'll be able to take away with you. Yeah, I could weld a nut on if it didn't work, Matt. But thankfully the easy out got it. Then the next fun is getting the bolt off the end of your easy out because you just drove it in there with a damn hammer. All right. As you can see, there's no damage to the easy out whatsoever. This is hardened tool steel. So when you drive it in, again, it's turning this way, which is loosening the nut, but at the same time, it's driving itself in and burrowing deeper and deeper. So the harder you pull on it, the tighter it gets. And that's what gives you the ability to get things out. That's called a screw extractor. Or if you're going to look it up online, it's called easy out. Norm says easy outs are worth having around and left-handed drill bits. You're absolutely right. Those guys are just, that just saved me in a pickle just now. Because how else was I going to get that flush mount bolt out of there to continue dismantling things? Now, estimates. We should be able to remove this setup, but we have to take caution because remember, we know that there's wiring traveling up these columns in order to energize this control board. And there we are. It's actually on both sides. So we're going to go ahead and unplug things. Now, I'm going to need a pick to undo the tab to unplug that, because we can preserve that connection and reuse it in our future projects should we choose to need it. Thank you for subbing to Lockdown. Appreciate you guys. I think Lockdown is absolutely great to watch. He's a smart young kid. He's building great things out of leftovers. He is a man after my heart. As you guys certainly know, this is my jam. I love being able to save this kind of stuff. I'm not going to get impatient and just snip these wires. What I am going to do is break this damn connector. No, I'm not. Perfect. So now we're completely separated. Let's go work on the other side. We've got pretty much the same thing going on over here. But now it's a little bit more precarious because we've got this other side free dangling, which means if we lose grasp, all the tension is going to be placed on the wires and they're going to snap. So we've got to position it in a way so that we alleviate that. zip tie right there that's going to be troublesome. Let's get that guy out of the way. Perfect. Okay. So now we've completely disconnected this section. Oh, no, we haven't. We still have another connection here. Where does that disconnect at? I think this is the primary power. So let's grab us screw gun and we'll undo the back. See if we can find a place to unclamp that. All right. That's undone. Okay. I think this traces over to that side. What it appears. So let's keep unscrewing until we can find that trace. Pull everything loose. No, sir. Not today, Satan. You ain't ruining my treadmill today, devil. Better back up off me, homie. Okay. Interesting. So the PCB control panel is loose. Lockdown says legends, all of you. I think you are as legendary as the rest of us, friend. Okay. I'll show you what happened. So we undid the PCB board for the main control. It looks like it was already broken at some point. But that's neither here nor there. We don't need it. We could find the umbilicals for our two lines that go down each of the legs here. And this is the one in question. that is traversing down that leg and preventing us from being able to remove this top section. So let's go ahead and see if we can't get this bad boy loose. Yep, it's just a pin set. Nice and simple. There we are. We've got a strain relief here. We've got another cable here that we can unplug. Now, once we thread these out of their respective areas, this is an absolutely crucial set of wires we want to keep. We want to keep these two because that's what controls this emergency stop. And even if we don't use anything else, having this e-stop is certainly a good thing to have. To have an emergency disconnect on any tool we're going to build, that's a bonus. All day, every day. So we're going to let that fall on its face because I'm a moron. I'm going to reposition this back up here. I'm going to disconnect a couple of zip ties here. Which now I believe gives me free license to start removing all the rest of this. And most of it is put in with zip ties. Just snip them off, replace them later if you need to. Let's get you back over here out of the way before you hurt yourself. Okay. We'll find out what more of these do later. But in the meantime, all we got to do is disconnect. So let's grab a screwdriver and start undoing more. Here's our ground. Here's a strain relief here. Another one here. Okay. If you haven't already, make sure you like, comment, and subscribe. Man, thank you, Lockdown. Appreciate you for that reminder, man. All right. Good. Good, good. We're making some progress here. Looks like we'll be able to unplug. Yes. Perfect. Okay. Got a couple of more strain reliefs to undo. All right, Norm. Thanks for coming in, brother. I'm going to keep undoing strain reliefs here. Okay. Now this, if that's all seated there, but we got an angled heat sink over here for this other subboard that we'll need to take out. Okay. Good afternoon, Kevin. Keith, you want me to stay on live? I'll be on live as long as it takes for me to get this thing out of here. I got you, man. Everybody else is like, screw this. I'm fucking out of here. He's going to be out here all afternoon doing this shit. Good to see you, Mr. Ellis. All right. Another ground wire here. Good. Perfect. Now we'll unscrew this VGA connection for the diagnostic computer for them to reprogram the treadmill. We'll be using that later, but not in their intended purpose. We'll hook up our VGA to an Arduino and reprogram the control board once we get to that point. We're not quite there yet. All right. And we'll pop all that loose. What's left here? 2 ISO connections there. And we're good. We've got the emergency switch off intact, which is great. That's a big win. I am playing with stuff again, Kevin. I love it. All right. We got our display. We got our controls, which is this is really what we needed. We needed the controls. We don't necessarily need the display, but it might be nice. You know, for a top of the line treadmill that's supposed to cost thousands of dollars, this thing is awful rudimentary when you get down into it. I mean, I guess when you think of its application, it doesn't have to do a lot. All it has to do is control a motor. We need our smaller socket. All right, you stay down there on the floor. We'll be back for you in a minute. Amongst many other things, I think potentially we have a motor upgrade here, Kevin. rather than the 2.25 horse that I had originally spec'd, we found this one with a continuous duty 4 horsepower motor. Okay. Let's pop that sucker apart. I'll throw that away in a second. With the prerequisite beer every time you pick up the drill. Got to do that. Hi. Okay. Well, it only slightly clipped me in the jaw, but that's okay. Nah, I'm just kidding. It barely even brushed me. That was my dumb self for not paying attention to what's going on. Okay. Now we need to figure out how to get all of this wrenched free. And I think I just did. Let's see. I think that did it. Perfect. And now we have that assembly loose. So remember, if you're going to follow along and you're going to take apart a treadmill, remember, I know it seems like it's common sense, but these are the only 2 points that the manufacturer has to route these cables up for the electricity that goes up to this part and the computer control. So they'll have to take that into account at the time you are dismantling this, because all of this wiring is going to be hidden inside, and just wrenching it loose is going to end up possibly tearing up control systems that almost make all this work useless. See, another thing we want to do is preserve as many of these circuits intact as we can, so that we'll be able to reuse them in any future builds. Why reinvent the wheel? If they've already got a working system, and the system will do what's the most important thing, which is to turn that motor, why dismantle any of it? Leave it alone. Let it do what it does, and use it as intact as you can, especially if you're not someone that's intimately acquainted with electronics and how they work. Well, that's going to be the easiest way for you to get it done. Hello. That happened. Okay. After we thread that wire out, we got another piece of high tempered or pretty thick 3/16 rectangular toe beam. It happens to be curved, but that doesn't mean we can't reuse the steel later. I think I've got this one empty, so we can just break that down. Then we're getting closer and closer to the fun bits. Not my fun bits, but some fun bits. Yes. Perfect. More for reused metal. And that's some serious duty steel. I mean, it ain't playing around. All right. The sun moved on me, kicking my ass. It's all right, though. You guys are worth it. All right. Let's get this bullshit out of the way. Some damn cooling vent they had covered up. Try to make it look pretty. All right, let's run that to the trash. Okay. Okay. We got a warning, which I promise you, if somebody put a warning on something, they don't go to all that extra trouble unless it was important. Because people are inherently lazy, and if they ain't got to do it, they won't. So we've got a warning on there. Don't touch the electrical components of the motor until 10 minutes after you've turned it off. I bet you $1 if somebody looks at how long I've been live streaming. I think we passed the 10-minute mark. So let's go to work. Now we know that at the root of it all, at the end of all, this is what's called a permanent magnet DC motor. It means that it constantly runs on direct current the same way that the car battery in your car runs. You need direct current, meaning a positive and negative constantly staying in the same polarity in order for this to run. As opposed to motors that are in your house, they normally will run on alternating current, which means that the positive and negative will flip-flop back and forth at a rate of about, in America, 60 cycles per second, or 60 hertz. In England, it's closer to 50. So the components of these that are important that you may not be able to see is we've got, of course, our rotor and our stator inside of this casing. It's given with an aluminum heat sink in order to keep it cool. We have a flywheel out here, which is a heavy weight, allowing it to keep up its momentum and continue to turn if it disengages with power, so it slows down gradually. Or it can continue to move easier when it's introduced with a load, such as a fat ass that's over here trying to run on it. Okay, that was rude. I shouldn't have said it that way. Y'all get what I'm saying. Now, the other thing that's important with these is that inside there's two recesses on either side of this rear end. And inside those is a piece of graphite that's called a brush. You've heard people advertise on the television and whatnot that something is a brushless motor. Well, these are brushed motors, meaning that the electrical current runs through those graphite brushes in order to energize the stator and the commutator in order to make this continue to run. So let's figure out how to get this sucker apart. First thing is, I'm going to start getting some of this crap out of the way. Damn, I wish that sun wouldn't have moved on me. Oof. All right. All right, let's see how we can get this sucker undone. I think I can pull all of this. Just those two screws. Let's give it a go. Did I lose you guys? You still here? Sorry, I can't see. The phone's out there in the bright sun. I can't tell. Perfect. Thank you, Keith. Let's see if we can get this primary control board, this PCB, disconnected from the housing. Again, trying to leave as much of this intact as we possibly can for potential reuse later. Okay. So we're going to unhook the primary transformer. Maybe. Let go, sucker. What's the matter with you? Thank you. Okay. So now we've got that transformer. We can set that aside. We don't need that. Okay. There's AC leg number 2. AC leg number 1. Okay. Perfect. Okay. We have designations on the board so we can tell exactly where the AC power comes in. Let me undo a few more of these. I'll show you what we're looking at. Okay, let's go inside so we can get some shade and I can show you what's up. I'm gonna do my damnedest to try to get this put together so you can see what's going on. Let me reconfigure my visibility on the computer so that I can confirm I'm showing you as I intend to show you. What's not working? Everything is working phenomenal, buddy. We are good to go. It's not doing what we're going to have it do yet, but all right, now I can see the screen and I can show you. All right, so as you can see, this is what's called the primary control board. This has all the integrated circuits and all the logic chips that are controlling all of the power going out to the different components of the treadmill. For your intents and purposes, if you're going to reuse the motor as we intend to, you really got to take note of about 4 things on here, other than the control circuit. And that is, you'll notice that this one right here is labeled AC2. And right here, I don't know if you can see inside there, we have AC1. This is where your alternating current comes in. That's where your inline power from the wall comes into the board. And then you have these 2 here, which are designated M plus and M minus. Get real close so you can see that. M plus and M minus are the outputs going to the motor. So I'll connect one side of my motor here, one side there. Fun fact about that, one of the properties of a DC motor is that the M plus and M minus are interchangeable. And what I mean by that is, if I put M plus and M minus in one configuration, then the motor will turn clockwise. If I reverse them, it will still operate, but it turns counterclockwise. Something important to know, because your lathe, you want it to turn the work toward you this way. And if your motor's turning at the opposite direction, you can simply reverse that polarity and solve that problem. Salidosa, I am not speaking English. Sorry about that, friend. Whew. So we got the primary control board out, which was nice and easy. We can look at this. We can look up this model. There's our, we have a fuse for the incline right here. That may be our culprit as to why the incline wasn't working, because that seems to be blown. That's good. That tells us exactly what we needed to know, why the incline wasn't working and moving up and down the way we wanted it to. So the linear actuator, odds are, is fine. It's just that fuse blew. Now, we'll also need to figure out why the fuse blew, because that's going to be a big clue for us to figure out whether or not we can even re-engage that. All right. PCB is out. Whew. Take a second over here in the shade, because damn, that was kicking my ass. We'll break into some extensions here in a minute. Start popping out that motor. Because at the end of the day, I believe I don't see a secondary speed controller unless it's on this mechanism here. Remember these guys? This was on the front, connected to that auxiliary board. So we may, let's take a look at that. Well, we don't need to look at that auxiliary board just yet. We know that the knee bone's connected to the thigh bone, so we know where that goes. And that will give us the speed control we need in order to turn the speed up and down on the rotation of the motor. But the next thing we need to do is get the damn motor out of there. Whew. I know y'all don't want to go. It's hot as hell. Back out in the sun. Whew. All right. Turn y'all down that way. See what the hell's going on. Let's get my screw gun for the Phillips, which is right there. I need an extension for the socket. Hopefully this is long enough. That's what she said. Let's see if we can't start on working on getting this motor out of here. Nope. This is an M6. We're going to need an M5. Gratuitous vroom vroom. Everything is in good shape. Okay. All right. Get over here, see what the hell I'm doing. Oh no. Oh no. The fourth and final nut holding the motor in place has stripped out. Well, maximum effort. Let's go. Oh, all of that is stripped out too. Good God, somebody went in here and did a number on this guy. Okay. Well, what are we going to do? We only have one choice. We're going to go after that bolt from the reverse and gouge it out of there. No, I ain't welding a nut on it. I'm kidding. Not that there, I can't get a welder in there. I got maybe 36 edge of the motor and the housing. I wouldn't be able to get a welder in there if I could. And some other people may encounter this and they don't have a welder. So we are going to show them how to beat it up without it. I'm doing good, Jacob. How are you, friend? Grinder and paint make me the engineer I ain't. All right, let's get it. Let's see if that removed enough threads for me to pop this sucker loose. Yes, sir, it did. Excellent. Okay. Hot damn. I think it did. Behold! It is done! One permanent magnet, 4 horsepower DC motor. Everything is intact. Nothing has been busted. Awesome sauce. All right, let's go back inside. And there we are. There's our big boy. So, give me a second. Regather myself. That's a little bit of hoof. I think we learned a lot today. We figured out how to run an easy out. We figured out how to get this big guy out of the treadmill. We also figured out how to get the speed controller, the main PCB. We got all of that out, which we'll be able to reconnect because we took the moment to undo all of the connections properly, so we don't have any issues later. The same size and shaft I made my 2x72 belt grinder out of. Yes, I think that this motor is more than stout enough for just about any application we're going to want in a wood shop. Maybe even some metal applications. That sucker does not look like it plays. Now, while I'm at it, a couple more items to note before I do the humdrum stuff, which is to go out there with a grinder and a zip disc, cut up the rest of that steel. Which I want you to take note of, some of the other items here, is that in here, let's just get a screwdriver and I'll show you real quick. Let me find a big flat blade. That will let me show you what we're looking at. All right. I'm going to try to remount you here. Give me a second. Two secs. All right. So right here, these will unscrew, and contained inside are the pieces of graphite that I was referring to. This is a motor brush. What's happening is current is passing down this wire, is electrifying the graphite and transmitting power to the commutator inside the motor. Now these, I had to take these open anyway because it does look like they're absolutely in good shape. So we are good to go in that regard. We don't need to replace any. That thing is already set and ready to rock. So we'll go ahead and put that boy back in his original position. And if you notice, there was a spring. And what that spring is doing is continuing to apply pressure against the brush so that it remains in contact with the commutator. As it passes by, it wears it away. And as it gets smaller, the spring will continue to advance it forward and keep it contacted. I think this thing is good to go. Next thing that we have here of interest, well, I think it's interesting, maybe you won't, is you'll see this chip right here and this weird wheel that's on the back of it. Now what that weird wheel does is, if you'll notice, I'm going to readjust the tripod here. Get you guys in a little closer so you can see what's up. Okay. Now, if you look, there's a piece of reflective tape right here. And as it turns, that tab is making a pass next to this circuit board here. What that circuit board is doing is called a Hall effect sensor. What it's doing is it's counting every time that little magnetic tab passes by it. 1, 2, 3. This small wire here, this one is going to be for the temperature sensor. So what that's doing is that's counting 1, 2, 3. And it measures that against the clock. And the faster the motor is rotating, the more times that little piece of foil is going to pass by this sensor. That sensor then reports to the main board, which we have over there, and tells the main board exactly how many times this thing is passed, which lets it do the math and understand how fast the motor is turning. That's the primary control board's speedometer for the motor. And this does hook to a temperature sensor that goes over there on the main board. I see the connector right there. Yeah. CF sends, yeah, Celsius and Fahrenheit sensor. And that's just there to protect it in case that this thing starts getting too hot. There's a thermal shutoff on the main board that'll shut the power off to keep this from burning up. Whew. I hope, if anything, you guys found that interesting, maybe even a little educational. I don't know. Or at the very least, entertaining, watching me bumble around in the driveway, tearing up a damn treadmill. But there are so many things that we got out of this. We got square stock steel. We got a cornucopia of fasteners, nuts, bolts, washers, bearings. We got a whole slew of those that we'll be able to reuse. We got some pieces of rectangular tubing down here that we'll be able to repurpose. We'll be able to repurpose all of this steel. I'll cut it up with a zip disc, but like I said, you guys don't want to see all that. Some aluminum extrusions, about 4 feet long, pretty heavy duty, thick stuff. And the granddaddy of them all, we got this bad boy right here, which I couldn't be more proud. 4 horsepower continuous duty. That thing is going to be a beast. For it to be in a commercial treadmill like this and be 100% duty cycle, I could not have asked for a better choice when it came to a motor for the machine tools, regardless of what I end up building, whether it's a lathe, a grinder, a belt sander. I mean, there's a whole variety of things. Yeah, that dragging the melamine board, it was in pretty warped shape. Looked like it might have got rained on or something, so I tossed it. But back out here, for those of you of the metalworking persuasion, we got a whole slew of this rectangular tubing that we're going to be able to repurpose once I cut it apart. We got a good piece of 3/16 A36 plate steel over there. Some good channels, some square tubing. All in all, this was a good haul. This was a very good haul. Kevin says, you know, Mike, what do I know? Tell me all about it. Oh. And on top of all that, I almost accomplished giving myself a damn heat stroke, which is good. I do have 90% of the parts for a drum sander. I certainly do. I got the parts for a wide belt sander too. Why don't you look at these guys? Look at them honkers. That's what she said. Those are some big mamma jammas. That's what I told her. Probably what, 3.5 inches across, 1-inch shaft. All in all, ladies and gentlemen, I think that was a pretty substantial haul. Absolutely. There's so many applications for so much of this stuff. Once you get it out, there's more bearings in one of these than anybody would ever even think. I mean, just these barrel tubes probably have 8. There's 4 bearings in each one of them. There's another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sealed bearings out there that I pulled out. And I can't be more happy. Plywood, I want you to see this. Look at this. Oh, Lord, look what we got. Look what we got. Looky, looky. Four horsepower continuous duty cycle. Look at that mamma jamma right there. At only running 100 volts. You know what? Let me take a look. Because I think the smaller one runs 130 volts. So I could actually run this thing with my existing speed controller, I bet. And then I've got, of course, the control circuits there, the main board. This one monitors speed with a Hall effect sensor, which is pretty cool. That was a hell of a haul, especially for free. Somebody down the way just decided to throw it out. They didn't want it anymore. I could run it off 240-volt batteries without a problem. Now, how long it'll run, couldn't tell you. Flacco says, shoot him an image of the main PCB. Hold on a second. Screenshot. Yeah, it didn't take very long to disassemble it. It didn't take long at all. But I promise you, this is the thing that I am happy with out of all of it. To be able to have a 4 horsepower motor that'll run 100% duty cycle is just incredible. You don't come across them every day. In your regular treadmills, they'll have a light duty cycle, 25, 30%. For this to be continuous duty, let me tell you, I can definitely tell you, I'm going to put this summit to work. It's going to definitely go to work. So, what do you guys think? Let's talk about it. Because I already had the 2 1/4 horse ready and mocked up so that I could make a lathe out of it. However, a 4 horsepower will most certainly make a badass lathe. It might actually even give me enough steel out here and the strength of that 4 horse. I might actually be able to make a tool rest and make a metal lathe. And if I can make a metal lathe, it'd be on. Okay? We ain't even playing after that point. Friends Woodwork Octar, good to see you, friend. Greetings to Pakistan. How is everything over there, friend? Oh. Zocco, I might call you after this live if you're fired up about it. I think we could do some cool shit. I think this PCB is good shape. The linear actuator on it was screwed, but I think it's because I got a fuse in here for the incline and it looks like it's popped. So that's why the incline wasn't working and they decided to toss it because the incline didn't work. See, that's another thing that I thought about is finding an old lathe without a motor. It's an easy conversion. I've already got everything I need. I got the pulleys. I've got a belt drive. Everything just came out of that treadmill to be able to do everything I need to do to convert an older lathe into being able to run this new motor. And having variable speed is a huge benefit. Absolutely huge when you have a lathe. So I think all of this, I don't think any of you guys want to see me use a zip disc and cut up a bunch of damn square tubing. I'm sure you guys would find that a little boring. Thanks for hanging out with me. I think I'll let you guys go watch somebody a little more worthy. Yep, being DC, that's absolutely true. Once again, remember, if you're going to take apart one of these treadmills, I've got ways that I can help you be able to walk through it. Reach out to me. My email is in my description. I'm more than happy to walk you guys through it. But if you see a treadmill, don't let it pass you up. That sucker has got a gold mine of things in it if you know what you're looking for. Love all you guys. Hope you have a good rest of your weekend. Take care. We'll see you next time.